something out there in the physical universe. But there is another level to the answer which needs more information before it can make sense, so we'll just have to wait. Right now, it's worth repeating the inescapable conclusions of the double-slit experiment. According to quantum physics, the atoms, nucleus and electrons, that make up the physical universe we consider to be so solid and so real only appear to be solid and real when they are being observed. When they are not being observed, they return to a wave state of infinite possible locations. Now let's talk about how an observer changes an electron from a wave into a particle. Wait a minute. No one really knows the answer to the question of how or why the observer changes an electron from a wave into a particle. The experts can only speculate. As Dr. Fred Alan Wolf, theoretical physicist, says,
particles are really what they seem to be. They're momentary manifestations, momentary poppings of this deeper imaginary realm, this wave-like realm, this implicate order, as David Bohm would say it, this quantum wavy function, as quantum physicists might talk about it, in which there is no particle. There's just this waviness which can spontaneously pop out as particle.
In other words, when an electron is viewed by an observer, these waves of possibilities pop and assume a specific location in space and time, which is what we see as reality. This is called collapsing the wave function. Collapsing the wave function can be very successfully explained and predicted mathematically using complex quantum mathematics, but it's very hard to describe in simple English. Basically, it means an electron normally lives in a wave state, a wave function, that includes many possibilities of where it could end up as a particle. And when the electron is observed, those multiple wave states are collapsed to one state, the state of being a particle in a specific location. Physicist Nick Herbert says this sometimes causes him to imagine that behind our back, the world, where we are not looking and cannot observe, is always, quote, a radically ambiguous and ceaselessly flowing quantum soup, unquote. But whenever we turn around and try to see the soup, our glance instantly freezes it and turns it back into reality. Herbert believes this makes us all a little like Midas, the legendary king who never knew the feel of silk or the caress of a human hand because everything he touched turned to gold. Herbert said, likewise, humans can never experience the true texture of quantum reality because everything we touch turns into matter. So where are these electrons living as waves of possibilities when no one is observing them and collapsing their wave function into a particle? The answer to that question has gone through a lot of revision over the years and has been called a lot of things as the research has progressed, including